are focusing on exponential functions, and you guys are going to tell me today, without graphing, if something is going to have exponential growth or exponential decay. So I'm going to give you guys a couple equations, and I'm going to try to zoom in on these if I can. It's just hard with Desmo. So if I do something like this, an exponential function is something where the x is in the exponent, like this. All right, we graphed those last week. Do you guys think that's growth or decay? Just by looking at that graph, do you think that that shows growth over time or decay over time? Growth, because it's an increasing function. It starts out small and then it gets large.
Interruption. Could I have Will King, Courtney Ridgway, Gabe Fertile, Lexi Baker, Dawson Lamb, Mindy Lay, Carlos Aparicio, Katie Turley, Jacob Cox, Grant Bell, and Rachel Donaldson to the comments.
All right, so on this one, I just want to ask you, what is the base for this exponent? What's the base? The power is x. What is the base? Is it? The base is 2. Now, I'm going to graph another equation. I should probably put that in parentheses. All right, now if you look at this, when I did 1/3 to the x, it graphed in blue. Is that growth or decay? You know what I'm saying? It's decay. It starts out big with bigger values, and then over time it gets smaller and smaller and smaller, close to 0, but never crosses. What do you notice between these two? Look at the bases. What do you think about this base makes one growth and one decay? One's a fraction. I'm gonna say, is it a big fraction or a small fraction? Do you think 1/3, is that a big number or a small number? I'm gonna say, there's actually fractions that show growth. Do you want to see one? So you guys might want to write these down. Just write in your notes that y equals 2 to the x is growth, y equals 1/3 to the x is decay. Now we said, you know, the base was a whole number and it was growth, and it was a fraction, it was a decay. But I'm actually going to show you guys that there's a fraction. You can have fractions that show growth as well. All right, do we see this third equation in green? 5/2 to the x. Do you see how this green equation is showing growth? So fractions can show growth too. So now I want to ask you, do we now notice a difference between the two fractions? Say, what do you notice about these fractions? This one shows decay and this one shows growth. Do you maybe could make a connection between those two fractions? So do you,
A proper fraction is decay and then improper is growth.
Okay, do you guys agree that 5/2 is an improper fraction? Improper fractions show growth, and then a proper fraction, one that the numerator is smaller, that's actually going to show decay. And the reason why is because if you actually made 5/2 a decimal, what is 5/2? That's really 2.5. So whenever you are looking at exponential growth and decay, there's a short little rule, and we are going to write those. So the first thing we want to look at is this. All right, so with an exponential function, you have a base and then an exponent. If your base is larger than 1, it is growth. So it doesn't matter if it's a fraction decimal or a whole number. As long as it ends up being bigger than 1, it's going to show growth. And if it's less than 1, it shows decay. No, and we never have anything equal to 1, and I can show you why in just a second. So if it's bigger than 1, it's growth. If it's smaller than 1, it's decay. And if you have something, all right, let me close out all of these. In an exponential function, you're never going to have a base of 1 because it looks like a flat line. What's 1 to the first power? What's 1 to the 10th power? What's 1 to the 20th power? So it just kind of stays a flat line. You'll never have a base of 1. So it's either bigger than 1 or smaller than 1. So whenever it is bigger than 1, it is growth. And when it's less than 1, it's decay. So I'm going to give you guys some examples. And you guys are going to tell me growth or decay. All right, so for the first one, I give you an equation that looks like this. Is that exponential growth or decay? All right, that is definitely growth. 4.3 is much larger than 1. All right, what about this one? All right, if we found a decimal of 7/8, would that be more than 1 or less than 1? All right, 7/8 is definitely not a whole, so that is decay. What about 0.7 to the x? That's decay. So far, so good? All right, we've only got one more thing to talk about, and then I'll let you guys work. What do you think happens if I add this? Do you think adding a coefficient makes a difference? So sometimes you do have coefficients in front of your base. The base is still 2. So whatever the base is what you go with. The coefficient actually has nothing to do with the growth or decay. And let me show you on Desmos really quick. And if you guys want to get your Chromebooks out and type these in with me so it's a little bit easier for you to see, let's go ahead and do that. All right, I actually want you to type that y equals 2 and then in parentheses 3 to the x power. So if we see, once you have it typed in, I'm going to say we're just going to desmos.com and opening up a blank graphing calculator. So when you add that coefficient of 2, when it's just 3 to the x, it's growth. When I put a 2 there, it's growth. When I put a 20 there, it's really growing. Now, if I make something like, if I even put small numbers in, so if you can see, whenever I have this base of 3, when my base is bigger than 1, it's growth. It does not matter what that coefficient is in front. If you have something like 6.5, it stays growth. If you change it to something really little like 0.0009, it's still growth. If you change your base to a fraction, if you put 1/4 in front of it, it's still growth. So whenever you are looking at an exponential function, if you have a number being multiplied to the exponential part, that coefficient in front really doesn't play a factor in the growth and decay. It plays a factor in like as far as stretching and shrinking and how far it grows, but it's still growth. And so we just want to recognize that. So if we want to go back to this page, so anytime if you have a coefficient in front of this, you're only looking at the base. This value has no effect on growth or decay.
Teachers, please excuse the interruption. I need the following students to please report to the commons area. Deb Smith, Noah Kincaid, Bonnie Witt, Malachi
So
Kaufman,
this
Gary
is the
Couch,
number we look at.
Andrew Shepler, Austin Burkhart. Please come to the commons.
So we only look at the base that's with the power. So now let's see if you guys can tell me some of these and if it's growth or decay. All right, we've got two numbers to look at. We've got a 7.5 and a 0.3. Which one is the base for the power? The 0.3. So on this one, the 7.5 has no effect on growth or decay. We're looking at the 0.3. Is 0.3 more than 1 or less than 1? All right, so is this growth or decay? This one is decay for sure. I probably should have written up there. We looked at it on Desmos, but that one is growth. All right, is this one growth or decay? It is decay. Which number determines that? Yep, the 1/2 determines that. Now, what do you guys think? Because that is it. It's easy. Now, just a reminder, we are going to just do a quick review assignment. A few years ago, we had some remediation sheets that if someone didn't do well, we required them to do the remediation before they could move on. But we have rearranged, that's what we used to do during ACT, but now we do lessons. So it is a little bit different. But I have one of those old tests that I used to do for remediation posted for tomorrow. It looks a lot like the quiz will. And so this quiz is going to be very, very short. I will tell you guys tomorrow in the morning, I will be having virtual kids from Algebra 2 coming in to test in the morning. So if you need a Google Meet, if you have questions on any of this, it'll have to be in the afternoon. So just email me, and even if they're testing, if you want to do a Google Meet, you can email me in the morning. We can set up a time so that way we're good to meet in the afternoon. That was the only thing that I wanted to say about that. Now, I do have paper copies today, or you can do it online. It's your choice. If you guys would like a copy, say I've got my day 2 paper copies over here right next to the day 1s, and you guys can turn those in, and I will get all grades updated tomorrow. But you guys are more than welcome to grab those if you would like.